Episode 3 Permissions, canUseTool, and Hooks. This is the densest mental model in the SDK, and the docs spread it across 3 pages. We will collapse all 3 into one ladder you can hold in your head. 5 steps. Build bottom up, because that is also the order you write them. At the bottom, canUseTool, your callback. The catch-all that fires whenever Claude wants a tool and no rule has resolved the question. Y or N sanitize the args, propose a remember rule, whatever your app needs. Above it, allow rules. Allow tools pre-approves a list. Settings.json adds more. Tools not in the list fall through to canUseTool, then permission mode, the global posture, default, accept edits, bypass permission, plan, don't ask, and on TypeScript, auto. Above that, deny rules, scope patterns like bash open parent rm star. These block even under bypass permissions. And at the top, hooks, your code runs first. A hook can allow, deny, modify the input, or defer the decision entirely. First step that denies, denies. First step that allows, allows. Let's walk it. Here is the flowchart. The tool request enters at the top, falls through the 5 steps, and gets resolved at the first one that matches. Hooks run first. A hook can deny outright, defer the whole query to be resumed later, or pass it down the ladder. Deny rules, check next. Bash open rm star matches, the call is blocked. Nothing below this step can rescue it. Not bypass mode, not your allow rules. Permission mode is the third gate. Bypass permissions approves everything that reached this step, except edits, approves file ops, plan denies writes, default and don't ask fall through. Allow rules pre-approve the listed tools. If the tool was in allow tools, we stop here with an approve. And if nothing has resolved by now, canUseTool fires. Your code decides. One quote from the docs worth memorizing. A hook that returns allow does not skip the deny and ask rules below. Those are evaluated regardless. Hooks live at the top, but their allow is not a get out of deny free card. 6 modes. Default is the one you start with. Nothing auto approves. Anything unmatched flows down to your canUseTool callback. Don't ask is the headless cousin. Same allow list behavior, but instead of prompting it, denies. Use it when you have a fixed tool surface and want a hard deny over silent reliance on canUseTool. Accept edits auto approves file edits and the file system shape bash commands. mkdir, rm, mv, cp, sed. Useful while prototyping in a Scratch directory. Note that accept edits does not cover MCP tools. Episode 2 flagged that footgun. Bypass permissions approve everything that gets past hooks and deny rules. Use only in sandbox environments. Plan restricts Claude to read-only tools. Reads, grabs, no edits. Ideal for code review. Auto is TypeScript only. A model classifier decides each call. Opt in when you trust the classifier. You can set the mode once at query time or switch it midstream with set permission mode on the query handle. Start strict, loosen up after a few good turns. Reading the docs, you might think allow tools combined with bypass permissions gives you a fast, headless agent that can only read. It doesn't. Allow tools is a pre-approval list, not a deny list. Tools not in it are not denied. They fall through to the permission mode. And bypass permissions approves whatever falls through. So bash, write, edit, every MCP tool all approved. The docs are explicit on this. Allow tools does not constrain bypass permissions. If you need bypass speed but want to block specific tools, use disallow tools. Bash open parent rm star, write. Each of those will be denied at the deny rule step, which runs before the mode check and stops call. Better still, drop bypass entirely and pair allow tools with don't ask mode. Lockdown agent, no escape hatch. 2 rule shapes. The difference is bigger than it looks. A bare tool name in disallow tools removes the tool from the catalog. Claude does not see it, cannot attempt it. will not even mention it in a plan. That is availability. A scope pattern, the tool name with parentheses and argument like keeps the tool visible but denies calls that match. Claude can still try other bash commands, just not rm and star. That is permission. Allowed tools is always pre-approval, not deny. Listed tools auto-approve, unlisted tools fall through. Pair it with don't ask mode and you have a lockdown agent. The 3 read-only tools approved, everything else denied without a prompt. No canUseTool callback needed. canUseTool fires when nothing earlier in the ladder resolved the question. 3 arguments. The tool name, the input Claude is proposing, and an options bag with an abort signal you can use to cancel plus suggestions, which we'll get to in a moment. 2 return shapes. Behavior allow with updated input runs the tool. Updated input is the part that matters. Claude does not see that you changed it. You can sanitize a path, scope a command to a sandbox, swap a destructive flag for a safe one. Silent rewrite. Behavior deny with a message blocks the call. Claude reads the message and may pivot to a different approach. Good messages explain why and suggest what to try instead. Updated permissions is for approve and remember. We see it on the next slide. 3 patterns cover most apps. 1. The terminal Y or N. Print the request, read a line, allow or deny. 20 lines ships a real app. 2. Modify on the fly. The user said the path is fine. You rewrite it to a sandbox subdirectory before the tool runs. Claude sees the result of the sandbox call and never knows you intervened. Sanitize paths, add timeouts, clamp limits. 3. Approve and remember. The 3rd argument carries suggestions, ready-made permission update entries the SDK proposes, filter for the ones with local settings destination, echo them back in updated permissions, and the SDK writes the rule to .claude/settings.local.json. Next session, the prompt doesn't fire. That is how you build a do not ask again checkbox. 1 pure footnote. If you are on Python, canUseTool requires streaming mode plus a dummy PreToolUse hook that returns continue_true. Without that hook, the stream closes before the permission callback can fire. TypeScript does not have this requirement. Pass canUseTool in your options and it works. That is the entire Python caveat. Moving on. The hook catalog is bigger than you need on day 1. These are the events that come up in real apps. PreToolUse fires before every tool call. This is where most of the action lives. Your hook can allow, deny, ask the user, or defer. It can also rewrite the input. PostToolUse fires after a tool returns. PostToolUse failure fires when the tool errored. Together, they let you log, audit, and inject context for the next turn. User prompt submit fires when the user sends a message. Inject project context, rewrite, attach metadata. Stop fires when the agent ends a turn. Save state, drain queues. Session start and session end, TypeScript only, fire at the very edges of the session. Telemetry, cleanup of temp directories. Subagent start and stop bracket subagent runs. We use those in episode 4. Pre-compact fires before the SDK compacts the conversation so you can archive the full transcript. Notification fires for agent status messages. Forward to Slack page on call. TypeScript adds a handful more listed below. Those are the headliners. The rest you reach for as you need them. 1 output shape worth memorizing because the doc spent a paragraph warning about it. Top-level fields apply to every hook. System message shows a string to the user. Continue. In Python, continue underscore controls whether the agent keeps running. The interesting fields live in hook-specific output. Permission decision is the verdict. Allow, deny, ask, or defer. Permission decision, reason tells Claude and the user why. An updated input rewrites the tool's arguments. 1 footgun. Updated input only takes effect with allow or ask. With defer, it is silently ignored. With deny, the tool doesn't run at all, so there's nothing to update. Always pair updated input with allow. Forget hook event name inside hook specific output, and the SDK can't tell which hook type the output is for. Always include it. When you register more than one hook on the same event, they all run in parallel. Authorization, validation, audit. 3 hooks, 3 things in flight at the same time. The order they finish in is non-deterministic. So write each hook to be independent. No, this one runs first, so I can rely on its state. And when they return different verdicts, the most restrictive wins. Deny beats defer, beats ask, beats allow. A single deny anywhere in the set blocks the tool. The other hooks don't get a vote. Matchers are regex against the tool name. Write pipe edit catches both file writing tools. Caret MCP __ catches every MCP tool. No matcher at all catches every call. The mistake every newcomer makes: matchers do not look at the tool's arguments. You cannot write a matcher that says only fire for writes ending in .md. You filter by tool name in the matcher, then by argument inside the callback. Read tool input.filepath or tool input.command and decide there. All 3 compose 25 lines of real code. First hook, block.env writes, matches, write and edit, reads the file path from tool chunks input. If it ends in .env, return permission, decision deny with a reason. Other paths return empty, which means pass. Second hook, sandbox redirect, matches write only, returns permission. Decision allow with updated input that prepends /sandbox to the path. The write still happens, but inside the jail. Claude does not see that you rewrote anything. Third hook, bash audit, matches bash. Logs the command with a timestamp, returns empty, pass through, pure side effect, and the registration at the bottom. 3 matcher blocks. They run in parallel for every matching tool call. Blockenv wins with deny for .env paths. Sandbox runs for all other writes. Audit runs for every bash command. 3 independent hooks, 1 tool stream. The whole ladder, one more time. Hooks at the top, your code. Deny beats defer, beats ask, beats allow. Deny rules below. Permission mode below that, 6 of them. Allow rules. And canUseTool at the bottom for everything else. That is the entire permission story. 1 ladder, 5 steps. First deny wins, first allow wins. Next episode, subagents, context isolation, focused prompts, parallel work, and one nasty corner of the permission story we did not cover today. Subagents inherit bypass permissions and accept edits from their parent, and they cannot override it. Your lockdown main agent can still spawn an unconstrained subagent if you are not careful. See you in episode 4.